model.
Yes, sir.
So up to last class, we were doing force exerted by magnetic field on a charged particle, right? We have finished force acting on a charged particle by magnetic field. And we started path of charged particle in magnetic field. So Anshika, what will happen if a charged particle starts moving parallel to magnetic field? What is the force on the charged particle if it is moving parallel to magnetic field? Anshika?
Sir, it's 0.
Yeah, the charged particle is moving parallel to magnetic field and the force is 0. Force is 0 because angle between velocity and magnetic field would be 0. So charged particle will not experience any force, its path will not change, will continue to move in the straight line path. And what will happen if it is moving anti-parallel to magnetic field? Yes, what will happen if a charged particle is moving anti-parallel to magnetic field? Then again your force will be 0. It will not experience any net force in that case also. Next, we have discussed this thing, Lorentz force. So what is Lorentz, not Lorentz force, centripetal force? What is centripetal force, Saifullah? What is centripetal force when a charged particle required centripetal force?
Like if an object is moving in a circular path, there's a force that will attract the object to its center. That is called centripetal.
No, it will not attract a particle towards its center, but that's a force which is required to change the direction of velocity. It acts towards the center, but it's not attracting the particle towards the center. And the magnitude of centripetal force was NV square by R. Its direction is along the radius towards the center of the path. We have discussed up to here. Now the next case is what will happen, and this is m omega square r. It acts along the radius towards the center, and it is also important that this is a requirement for circular motion. If a body is moving on a circular track, then it needs centripetal force, which is always satisfied by some external force. There's always an external force which will provide centripetal force. The next case is what will happen if a charged particle is moving perpendicular to magnetic field. You have to discuss the path of the particle if it is moving perpendicular to field. So you can remember this result. If a charged particle is moving perpendicular to field, then its path will be circular. We'll later prove why the path is circular, but you should first remember this result. Means if a charged particle is moving parallel or anti-parallel, then path will be a straight line. If a charged particle is moving perpendicular to field, then its path will be circular. Now, why the path of charged particle is circular, that we will do now. So let's take the case of magnetic field. This is the magnetic field on the charged particle. The direction of magnetic field is inverse. It's acting in inverse direction. Cross means inverse. Magnetic field is inverse. And this is the particle Q. It's moving with a velocity v in this direction. So velocity is along x-axis and magnetic field is along z-axis. So the angle between velocity and magnetic field is 90 degrees. We can first calculate the magnetic force on the charged particle. Just give me 1 second. So if the charged particle is moving perpendicular to magnetic field, then first calculate the magnetic force on the charged particle. Let's first calculate the magnetic force on charge Q. The magnetic force on charge Q is simply its QVB sine 90. Sine 90 is 1, so the magnetic force is just QVB. That's my first equation. What will be the direction of magnetic force? For the direction of magnetic force, we will apply right-hand thumb rule. Do one thing. First of all, draw this figure, this direction of magnetic field and velocity in your notebook. Draw this one in your notebook. Draw this one in your notebook. Then only we can apply right-hand thumb. Okay, I hope. Now place your finger in the direction of velocity. Velocity is to the x-axis. And magnetic field is inwards, and curl it towards the magnetic field, inwards. So when you place on your notebook, this is like this. This is the direction of velocity, and you will curl it inwards. So in your notebook also, your thumb will point towards the y-axis, positive y-axis. So the direction of force is towards positive y-axis. This is the direction of force. Force is acting towards positive y-axis. Now, due to this force, the direction of particle will change. The particle, instead of going in a straight line, it will change its path. If we again see the direction of force, you again place your finger in the direction of velocity and curl it towards the magnetic field. This is the direction of force. This is the direction of force. You can repeat this thing again, like the charged particle is going in this direction, force is acting in this direction, the direction of velocity will change. If you again apply right-hand thumb rule, place your finger along velocity, curl its inwards, thumb will go in downwards direction. It will go here, then again the force will act in this direction. Now you can see the force is always acting towards the center, towards a particular point. And this is possible only if a centripetal force is acting on the body, which is acting towards the center. So from here, from this point, that force is always acting at a single point on the charged particle. You can conclude that path of the charged particle will be circular. The charged particle will move in a circular path if it enters perpendicular to magnet. This is the path of charged particle if it's moving with the velocity v. This is the center of the charged particle, center of the circular path. And this is the direction of magnetic force. At all points, the direction of magnetic force is towards the center. This is the direction of magnetic force. So this is the magnetic force on charge Q. Now, since the charged particle is moving on a circular track, it will need a centripetal force. So the centripetal force required by the charged particle. So the centripetal force that the charged particle will require is mv square by r. That's equation. Now, in this calculation, your task is to calculate radius of this circular path. It's moving in a circular path. Charged particle is moving in a circular path. So your task is to calculate the radius of the circular path. Then after calculating radius, your task is to calculate the time period, means the time taken by the particle to complete one revolution. After calculating time period, your task will be to calculate the frequency of charged particle. Now, since charged particle is moving on a circular track, the first step is you have to calculate the radius of the path. For radius of path, what we can do is we can equate this magnetic force with this centripetal force. The reason is this is the magnetic force which provides centripetal force. Magnetic force will provide centripetal force. See, read this statement. It is requirement fulfilled by an external force. So there is an external force which will provide the centripetal force, and that external force is magnetic force. So you can say that centripetal force Fc will be equal to the magnetic force. Centripetal force is mv square by r, which is equal to magnetic force, which is qvb. See, this square will cancel this velocity, and you will get that the radius of the path is it's mv by q. So again, if a charged particle moves perpendicular to magnetic field, its path would be circular, and the radius of the circular path is this mv by q. After the radius of circular path, the next task is to calculate the time period. So time period means time taken to complete one revolution. Time taken to complete one revolution. So the time taken by the particle to complete one revolution is known as time period. Now see how we calculate time period. We calculate time period by this relation. Velocity is distance divided by time. So the distance that this charged particle will cover is 2 pi r. The time is capital T. So we will be using this expression that velocity is 2 pi r divided by T. So the T time period T will be it's 2 pi r divided by V. So what is R? R is mv by qb. This is equation number 1. This is 2. I'm just substituting the value of radius from 1 to 2. So when we substitute 1 in 2, we get time period is it's 2 pi by v, its radius, it's mv by qb. So the time period is it's 2 pi m divided by qb. This is the time period, time taken by the particle to complete one revolution. After time period, the next task is to calculate frequency. Frequency means
1 by t.
yeah, frequency is 1 by t. Frequency means number of revolutions completed by the particle in 1 second. So frequency is just the number of revolutions completed by particle in 1 second. Completed by particle in 1 second. So in 1 second, the number of revolutions completed by the particle is frequency. You can represent frequency by F. Frequency is 1 by time period. 1 by time period means your frequency is QB by 2 pi. That's frequency. After frequency, there is another term which is angular frequency. See, angular frequency is just frequency multiplied by 2 pi, nothing else. Angular frequency. Omega. This is simply 2 pi multiplied by frequency. So if this is equation number 1, 2, I call this as 3, let's call this as 4. This is equation number 5. We can substitute the value of frequency from 4 in 5. So when we substitute 4 in 5, we get angular frequency is it's 2 pi into F, which is QB divided by 2 pi M. 2 pi will cancel this 2 pi. And the angular frequency will comes out to be its QB by M. So these are the parameters then one should calculate. If a charged particle is moving in a circular path, then the radius of path is mv by qb. Time period is 2 pi m by qb. And see, time period is independent of radius and velocity. There's no radius, no velocity here. So you can say time period is independent of radius and velocity. Next, after calculating frequency, you can also calculate the kinetic energy of charged particle. See, kinetic energy is half mv square. Let's call this as equation number 6, and let's call this as equation number 7. From equation number 1, you can calculate the value of velocity. Velocity is qbr by m. So from 1, you can say that your velocity is qbr by m. You can substitute this v here. So the kinetic energy is its half into m into qbr by m whole square. So it's half into m into q square into b square r square by m square. M and square will get cancelled out. So the kinetic energy of charged particle is q square b square r square divided by 2m. This is kinetic. So if charged particle is moving perpendicular to magnetic field, then you have to calculate all these parameters: radius, time period, frequency, angular frequency, and kinetic energy. Note it down and tell me if you have doubts in any step. And please try not to just copy paste all calculations. Anshika, Arpit, is it clear? Any doubts?
Sir, can you say how the direction is changing?
Direction of force is changing, right, Nabil?
Yes, sir.
Nabil, did you draw this figure on your notebook?
Yes, sir.
Okay. So do one thing. Take your finger, place them in the direction of velocity, that is along x-axis, and curl it inwards into the plane of your notebook. Where is your thumb going? X, Y, Z. In which axis is your thumb going?
Y-axis, sir.
Y-axis going. So if a force is acting in the upwards direction, then it's the direction of velocity should change. Earlier, a charged particle was going towards the positive x-axis. Force is acting along the y-axis, so the direction of velocity will change. It will go in this way. Apply right-hand thumb rule again. Now place your finger along velocity. Yes,
Yes.
Nabil. Now, what's the direction of thumb? Was the same point?
Yes, sir.
Again, velocity is going here. And force is acting in this direction. Its direction will change again. Repeat the same right-hand thumb rule again.
Yes, sir. Again, same point.
That's why I'm saying that point, if force is always acting towards a particular point, that means path will be circular. Hishma, doubts? Hishma, you were not there in the last class, huh?
No, sir.
You went through the recordings?
Yes, I will.
So,
Yes, sir.
so how come magnetic force and centripetal force became equal?
Centripetal force is just a requirement. It's always an external force which provides the centripetal force. Like when planets revolves around the sun, it's gravity which is providing the centripetal force. Same here. The magnetic force is an external force. This will provide the centripetal force. So if magnetic force is providing the centripetal force, then they should have the same magnitude, right? Then only magnetic force can provide centripetal force.
Yes, sir.
Miraj, doubts?
Oh, sir.
Safula?
The
Yes.
figure on what I'm saying.
Okay. Safula, doubts any step? Anshika, you were there in the last class or you were absent?
Done, sir.
Okay. Anshika, you were there in the last class or you were absent?
Sir, I guess I was not.
Sorry. Nabil Khan, doubts?
No, sir, no doubts.
Can I scroll it now?
Yes, sir.
Alia, doubt in any step? Can I scroll it? Vishma?
Yes, sir.
So final value of time is 2 pi m by qb, right, sir?
Sorry?
The final expression for time period.
Yes, it's QB by 2 pi m.
One minute, can you go up? Yes, sir. Then.
So that was about the path of charged particle if it is moving perpendicular. Note down this question. I will solve two parts. Part 1 and part 3 I will solve. 2 and 4 will be over. Just note down this question. Yes, everyone have written the question?
No, sir.
Okay. So if the charged particle is moving perpendicular to magnetic field, you have three particles, a proton, a deuteron, and alpha particle. They all enters in the magnetic field perpendicularly. That means the path of all particles will be circular. You're supposed to calculate the ratio of their radii, time period, frequency under different conditions. In the first part, the question says the velocity is same. That means you need an expression of radius in terms of velocity. This is what we have derived. This is mv divided by qb. You have to calculate the ratio of radius of path of proton, radius of path of deuteron. The second particle is deuteron and the third one is alpha particle. The radius of path of alpha particle. The radius is its mass of proton multiplied by the velocity of proton divided by the charge of proton into magnetic field. For all particles, magnetic field is same. Similarly, when you take deuteron, mass of deuteron, velocity of deuteron, charge of alpha particle, deuteron, and then the magnetic field, the same magnetic field. Then alpha particle, mass of alpha particle, velocity of alpha particle, charge of alpha particle into magnet. Is it? Nabil Khan, what is a deuteron? I need mass of deuteron and charge of deuteron. What is a deuteron? See, the mass of proton, we write it as P. Velocity of proton is Vp. Charge of proton is E and magnetic field is B. Okay, let me write the mass and charge of all particles. If you have this is mass and this is charge. If you have a proton, then we represent its mass as MP and charge as E. MP means 1.6 into 10 raised to the power minus 27 kg. And charge means 1.6 into 10 raised to the power minus 19 kg. This is for a proton.
Deuteron is twice the proton, mass of proton.
Yeah, deuteron, yes. The mass of deuteron is twice of mass of proton and charge is same as that. See, deuteron is an isotope of hydrogen. Similarly, if I take alpha particle, the mass of alpha particle is 4 times mass of proton and charge of alpha particle is twice of that of proton. So when we take deuteron, I will write twice of mass of proton. Velocity of deuteron is Vd, charge of deuteron is E, magnetic field is. When you take alpha particle, its mass is 4 times mass of proton. Velocity of alpha particle is V alpha, charge of alpha particle is 2e, magnetic field is B. When you take ratio MP, MP, MP will cancel out. Velocity, velocity, velocity will cancel out. Magnetic field, magnetic field, magnetic field will cancel out. E, E, E will get cancelled out. And when
Sir,
you take
deuteron is negatively charged, right?
no, all are positively charged particles. Deuterons is it's H plus. You take a hydrogen isotope of hydrogen, which have 1 electron, 1 proton, and 1 neutron, and then you ionize it. You remove 1 electron from it. It's positively charged. This alpha particle is basically He2 plus. This is H plus. This is also H plus. But again, here the isotopes are different. This have only 1 proton, this have 1 proton and 1 neutron. So the ratio is 1:2:2. This is the ratio of radii. What is the expression of time period? Expression of time
Sir,
period.
how did velocity got cancelled out?
Yeah, in the first part, it's given that they all are moving with same velocity. Okay, all charged particles are moving with same velocity.
Yes.
After radius, the next is time period. For time period, we can use this expression. This is 2 pi m divided by qb. This is the expression of time period. So we can take ratio of time period of proton. Then we can take time period of deuteron. Then we can take time period of alpha particle. And we can write this as it's twice of 2 pi mass of proton. I'm writing the mass and charges directly. Charge is E, magnetic field is B. Similarly, 2 pi mass of deuteron is twice of MP. Charge of deuteron is E into magnetic field. When you take alpha particle, it's 2 pi. Mass of alpha particle is 4 MP. Charge is 2E into magnetic field B. So now you can check this 2 pi 2 pi, 2 pi, it gets cancelled out. MP, MP, MP will get cancelled out. EB, EB, EB will get cancelled out. And this 2 will cancel this 2. So it's 1:2. That's the ratio of time. This is the answer when they are moving with the same velocity. I'm not doing second part. Second part will be homework. I'm doing part 3. When the question says they are moving in same kinetic energy. For same kinetic energy means somehow we have to express this expression mv by qb in terms of kinetic energy. I need to express this expression R is mv by qb in terms of kinetic energy. So we'll tell Noah, how to convert this expression in terms of kinetic energy? Noah.
So half mv square, we will be converting this equation into b. It will be r cube b upon m, then half mv.
See, kinetic energy is half mv square. You can get the value of V from here. Your V will be twice of mass into kinetic energy divided by m whole root. You can substitute this value of V here. When you substitute the value of E here, you will get radius is its mass by charge into magnetic field into V. V is twice of mass into kinetic energy divided by. So see this, not M is not inside the root, M is outside. Sorry, there's no M. So this M and root M will get cancelled out and you will be left with only root over twice of mass into kinetic energy divided by Q. This is the expression of radius of charge particle. Now what we can do is, so this is the expression of the radius of path in terms of kinetic energy. Take ratio. Radius of path of proton, path of neutron, path of alpha particle. This will be under root twice of mass of proton, kinetic energy of charge particle, charge E into magnetic field. Similarly, this is twice of mass of neutron is twice of mass of proton, kinetic energy is same, charge is same, E into magnetic field. When you take alpha particle, it's root over mass of alpha particle is 4 MP, kinetic energy is same, divided by charge of alpha particle is 2E into V. See, now you can cancel these terms. EB, EB, EB will cancel out. Kinetic energy, kinetic energy, kinetic energy will get cancelled out. Mass of proton, mass of proton, mass of proton will get cancelled out. And this 2 will cancel, this 2 will cancel this 2. So we are left with only, this is 1 ratio. There is 1, 2 left here, root 2. This is root 4. Root 4 is 2 divided by 2, it's 1. 1 ratio, root 2 ratio. Okay, Jasola, will the ratio of time period in case 2, means case 3 when kinetic energy is same, will be same as that of case 1 or it will be different? Will there be any change in the expression of time period or it will be same? Jasola,
I think it will change.
you think it will change, okay. Udeep, the ratio of time period, what do you think, it will change or it will remain same? Remain same means same as that of part 1.
Sir, time
Good
period velocity will be differently.
So it will change or it will remain same?
Sir, same ही रहना चाहिए.
Same, right. It will remain same. Very good, Alia. It will remain same. The expression of time period will not change. See, time period does not depend upon velocity. So whether your charge particle enters with the same velocity, with the same momentum or the same kinetic energy, does not matter. The thing that only matters is mass of particle, charge and magnetic field, which is not changing. So answer of time period for all the cases, they are moving with same velocity, same kinetic energy, same momentum. The answer will remain same. Okay. So the hint for part 2 is for the second part. You have to write this expression in terms of momentum. It's mv by qb. What is mv? Mv is nothing but momentum, so it will be p by q. Similarly, the answer for the fourth part. For fourth part, what you will do, you will put your kinetic energy equal to qv, where v is potential difference. This is what we did in chapter number 2. That kinetic energy is charge multiplied by potential difference. So instead of this kinetic energy, you can substitute qv. When you do this substitution, this is the radius expression of radius under root 2 m qv by q. So second and fourth part is a homework. First and third we have finished. Not enough. And remember this data, masses and charges of the particles. Nabil Khan, doubt?
No, sir, no doubts.
Can I scroll it?
Sir,
Yes.
so how is the charge of a proton 4.6 into 10
One
to
point.
the power minus 9?
No, it's 1.6. Sorry. It's a bracket. It's 1.6. 1.6. Yes. Can I scroll it?
Yes, sir.
Sir, how do you get instead of QE down?
Hmm? Sorry.
No, sir. Sir, could you just scroll a little bit up?
सर एक सेकंड ऊपर कर देना.
Sir, for the ratio of R2, isn't it supposed to be 2, sir? Because root 4 is it?
Yeah, but there is one 2 in denominator also, no?
Yes, sir.
You'll cancel it. Okay. Next, for fourth part is your homework, but if you want, you can just take screenshot of this hint. You can take this as a hint. Take the screenshot. So that was about the path of charge particle when it moves perpendicular. Now we'll discuss what will happen if charge particle is moving at some angle theta to magnetic field. Next part, if your charge particle is moving perpendicular to not perpendicular, at some angle to magnetic field, and that angle is neither 0 degree, nor it's 180 degree, nor it's 90 degree. This is something else, 30, 40, 60. It could be anything, but it's not 0, 180 or 90. then you should remember that path would be helical. Why the path is helical? This we will see. See, this is the magnetic field. This is the charged particle. It's moving with a velocity v. The angle between the velocity and the magnetic field is theta. So what we do is we first take the components of velocity. We take one component which is parallel to magnetic field. We write this as u cos theta. We call this as v parallel. V parallel means component of velocity perpendicular to magnetic field. Then we take another component u sine theta. This is the component of velocity which is perpendicular to magnetic field. So we will analyze the path of charged particle due to each of the component individually. We'll first analyze the path of charged particle due to parallel component. And then we will analyze the path of the charged particle due to this perpendicular component. We'll analyze the path of particle due to each of the individual component. So, Nabil Khan, what will be the path of charged particle due to this parallel component? Due to this component of velocity which is parallel to magnetic field, what will be the path of charged particle? Nabil Khan, check
Path
the
of
first.
charge.
Yes. Yes, you were saying something, sorry. Nabil Khan.
Yes, sir. Linear.
Linear, very good. Due to this parallel component, the path will be linear. So if a charged particle is moving parallel to magnetic field, its path will be linear, its path will be straight line. And what would be the path due to this perpendicular component, Nabil? Nabil Khan. The path of charged particle due to this perpendicular component of velocity. Path would be circular, I guess, huh?
Yeah, circular.
Circular. So due to this v parallel, the path will be straight line, and this due to this u perpendicular, path would be circular. So we will discuss both the paths individually. First of all, the path due to the circular component. So due to this perpendicular component, we know that path is circular. For circular path, we just need the expression of the radius and the expression of time period. What is the expression of radius for the circular path, Hishma? Due to this u perpendicular path is circular, right? I'm asking about the radius of the circular path.
MV by QB.
MV by QB. So instead of V, we will be using U perpendicular. We're taking the perpendicular component of velocity. You should remember this will be U sine theta. And the time period is same, 2 pi m by Q. And what will be the path due to the circular straight this U parallel? Arpit? What will be the path of particle due to this U parallel component? Arpit? Noha, what will be the path of particle due to this U parallel component?
Linear.
Linear. So this is straight line path. On the combined path, the sum of the circular path and the straight line path, which is helical. So combined would be in helical path, circular plus straight line. And this is how we draw the helical path. Helical path is the circular as well as straight line. For helical path, we need to calculate the distance between this distance. From here to here, time taken by the particle to move from here to here is capital. And the distance traveled is pitch. And to travel this pitch, which component of velocity we will use? Saifullah? To travel this pitch, the distance equal to this pitch, which component of velocity is responsible for pitch? V perpendicular or V parallel?
So V parallel.
V parallel. So see, distance is speed into time. So you can write pitch as U parallel multiplied by T. Is it? This is the combined path. So if a charged particle is moving at some angle to magnetic field, then your path will be helical. For helical path, we need two components. We first need the circular path. For circular path, we'll be calculating radius as well as time period. This one. And then straight line path. For straight line path, we will calculate pitch. The combined path will be helical. Note it down. And tell me if you have any doubt.
Sir, 1 minute, can you go up?
So is this chapter almost completed?
No, 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 no. This is 70% complete. After this lecture, I will need just maybe 2 or 2.5 hours more. And so this is the last lengthy chapter of this syllabus. All other are small topics.
After this, is there a theoretical chapter like the magnetism one?
Yeah, that is a very theoretical chapter. This will take only one lecture. If you go fast, then we can wrap up that chapter in one class. Extreme, it will take 3 hours. If you go slow, it will take 3 hours. If you go a bit fast, it will take less than 2 hours. All of the chapters are small. These first 4 chapters are very, very lengthy chapters. And these first 4 are a major part of the syllabus. Haji, can I scroll it? No?
Yes, sir.
Can I scroll it?
No, sir. Yes, sir. Then.
Okay. Okay, after magnetic Lorentz force, the next is the topic is Lorentz force. See, in Lorentz force, the charged particle is moving in a region which have both electric as well as magnetic field. So the charged particle is moving in a region having both the fields. So it will experience both the forces. The charged particle will experience electric force as well as the magnetic force. Does anyone remember the formula for calculating electric force? Like if a charged particle is in some electric field, what is the formula for electric force, Yoshika?
1 by 4 pi epsilon 0
No,
Q1,
no, no,
Q2.
no, no, no. That's Coulomb's law. I'm asking if you charge particle in some electric field E, then what will be the electric force? If this is field E and you place a charged particle here, Yashika, what is the formula for electric force here?
Sir, QE.
The formula is QE. If your charge particle is positive, then it will experience a force in the direction of you. So if a charged particle is moving in a region having both electric and magnetic field, experience both the forces, electric as well as magnetic force. The electric force is simply QE, and the magnetic force is QE cross B by Lorentz force. You can take Q as common and you will left with E plus B cross B only. That is the Lorentz force and the total force experienced by the charged particle. Note it down. We'll do one simple numerical on it. The major part of the numericals of Lorentz force is this cross product. If you can do this cross product properly, then Lorentz force. Written? Arpit, Tishma, Nabil Ahmed.
Yes.
It's okay. See, this is the next question. The charge is
Circular
given.
co-op.
Yes, yes. Yes. Can I scroll it now?
Yes, sir.
So this is the charge of particle, this is electric field, this is velocity, this is magnetic field. You're supposed to calculate the Lorentz force. So this is the formula F is Q, E plus V cross B. So the major part of this calculation is V cross B. So first of all, we will do V cross B. We'll first open the cross product. Once you have the cross product, then all other calculations are straightforward. So first of all, we will be calculating V cross B now. See, velocity and magnetic field both are given in Cartesian form. So if vectors are given in Cartesian form, then to calculate cross product, we solve the determinant. The first row is I cap, j cap, and k cap. The second row is the coefficient of I cap, j cap, and k cap. The coefficient of I cap is 1, j cap is -3, and k cap is not there, so it's 0. So it is 1, -3, and 0. For magnetic field, it's 1, 2, and 5. So this is 1, this is 2, and this is 5. When you open this cross product, this is I. When you take this is row and this is column. So this is -3 into 15, it's -15. 2 into 0 is 0. Then minus of j gap. This row and this column gets eliminated. And you're left with only 1 into 5 minus 0. Plus k gap. Row and this column gets eliminated. You have 1 in 2 and 1 in -3. So this is 2 minus 3. So we have minus of 15 I cap we have minus of 5j cap, we have minus of k cap. That's V cross. This is V cross P now. Minus of 15 I cap minus 5j cap minus k cap. Now, once you have V cross B, you can substitute the value of V cross B here. So when you substitute this value here, you get that your force is Q. Q is 2 coulomb. E plus V cross B. E is I cap plus 2j cap. I cap plus 2j cap. Plus V cross B. V cross B is this one. Minus 15 I cap. Minus 5j cap. Minus k cap. So your force is 2. It's I cap minus 15 I cap. It's minus 14 I cap. This is 2j cap minus 5j cap minus 3j cap. This is minus of k cap. When you multiply it with 2, you have it's minus of 28 I cap minus 6j cap minus 2k cap of it. So this is the force, Lorentz force acting on the charged particle, minus 28 I cap minus 6j cap minus 2k cap. Note it down. Is it clear? These calculations, Hishma? Unil?
Sir, can you share the question, sir?
Yes. I can show the question. And just please don't copy the calculations. Try to do it in your. If you're stuck somewhere in the cross product, just tell me. I will repeat it again.
Done, sir.
You all have maths, I believe, except Arpit. Arpit and Alia. Ishma, you have maths, no?
Sir, I don't have maths.
No, sir, I
Oh,
don't.
Miraj, you don't have maths. But you know this cross product from class 11th?
Yes, sir. Yes, sir.
You know this. Ishma? You know
Yes,
this, how to open this determinant, or should I repeat it again?
yes, I know.
Alia? You know how to do this cross product? You want to repeat it again?
So please.
Sorry?
So can you repeat it?
Okay. I should repeat. See, this is I cap, J cap, K cap, 1 minus 3, 0, 1, 2, 1. Okay. So we'll first take I cap. When we take I cap, then we just eliminate this row and we eliminate this column. So we just have minus 3, 0, 2, and 5. Then we take cross product, 3 with 5 and 2 with 0. So multiply 3 with 5, it's minus 15, minus 2 with 0, it's 0. Then minus of J cap. When you take J cap, the row and column will eliminate. So you have 1 and 5, 5, minus 1 into 0, 0. So okay, up to here. Second term is always
Yes.
negative. When you open this determinant, the second term is always negative. Plus K cap. When you take K cap, the row and column will eliminate. 1 and 2, 1 and minus 3. So that's 2 minus, oh sorry. It's not 2 minus 3, it's 2 minus 3. This is minus 3 now. Sorry. 2 minus 3. Everything. So it will be plus K cap. This will be plus K cap. This will be plus K cap. So this will be plus 3 I cap. This will be plus 6 K cap. So when you take K cap, this row and column will eliminate. 1 into 2.
Plus
It's
5
2.
k cap नहीं होगा?
Just I'm coming to it. 1 into minus 3 is minus 3. So 2 plus 3 is 5. 5. 5. 5. So this will be 5 plus is only 5 now. plus 5k gap. 5 2s are 10. 10k. Alia? Clear now? Just remember the second term is always negative. Okay. First is positive, third is positive, second is always. Yes, everyone have written?
Yes, sir.
Okay. So after this Lorentz force, you will get two type of questions on Lorentz force. One is this numerical type. Another is this type of conceptual question. So the question says a charged particle is moving in a region of both electric and magnetic field. Predict the direction of magnetic field if it pass undeflected. So this is your charged particle. This is moving along x-axis. Your electric field is along y-axis. You have to predict the direction of magnetic field so that it passes undeflected, so that net force on the charged particle is 0. Write down the question, then we'll start the calculations. Please write down this question, then we'll start the calculations. So the region have both electric and magnetic field. The direction of electric field is given. Electric field is along y-axis. You have to predict the direction of magnetic field so that the particle will pass undeflected. If particle is passing undeflected, that means the force on the charged particle is 0. Yes, written question.
1 minute.
Okay, let's start this question. Hishma, what is the direction of electric force? Hishma, Electric field is along y-axis, positively charged particle is going along x-axis. I'm asking for the direction of electric force. Yoshika, what will be the direction of electric force?
Sir, along y.
Yes, electric force will act along in the direction of electric fields along positive y-axis. So particle will pass undeflected only if the net force on the particle is zero. Particle will pass undeflected if net force on particle is zero. Particle will pass undeflected only if the net force on the particle is zero. The net force, if electric force is acting in upwards direction, then what should be the direction of magnetic force? If electric force is acting in upwards direction, Arpit, then what should be the direction of magnetic force so that net force is zero? Arpit. Electric force is acting in upwards direction, so magnetic force should act in downwards direction, negative y-axis. So the magnetic force is acting in downwards direction. This is the magnetic force. Now, charged particle can pass undeflected only if this electric force and this magnetic force will cancel each other, or they are equal. Then only they can cancel each other. So now you know the direction of magnetic force. That magnetic force is along minus y-axis. Now the question is predict direction of magnetic field B so that magnetic force is along minus y-axis. So you have to predict the direction of magnetic field so that your magnetic force is along minus y-axis. So magnetic force is along negative y-axis. Sorry, you have to decide what is the direction of the magnetic field. Force, you know, that's along negative y-axis. So see, your magnetic field and velocity and magnetic force, they are mutually perpendicular. Your velocity is along x-axis, your force is along y-axis. So field should be along z-axis. So you have two options for field. Field is either along positive z-axis or along negative z-axis. I'm repeating again, force is perpendicular to velocity, is perpendicular to field. They are mutually perpendicular. So if your velocity is along x-axis, your force is along y-axis, then your field should be along z-axis. So you just have to decide whether your force is along positive z-axis or it's along negative z-axis. So for this, what we can do is we will do hit and trial method. We will first assume that field is along positive z-axis, and we'll see by applying right-hand thumb rule, are we getting the force along down in the downwards direction? So just predict that your field is in this direction. Huh? This is the direction of field. Just assume that field is outwards. Place your finger in the direction of velocity and curl it in the outwards direction, out of the plane of your copy. So when you curl it outwards, your thumb will go in the downwards direction. So force is downwards, we need downwards. That means this is the correct direction. Now let's assume that field is inverse direction. Place your finger in the direction of velocity, which is along x-axis, and curl it inwards. The thumb will go upwards. But your force is not upward, your force is downwards. So that's the wrong direction. The correct direction is positive z-axis. Note it down, please.
Sir, how do you get forces in minus y direction?
It's because electric force is upwards. The net force on the particle is zero. Means electric and magnetic forces should cancel out each other. They can only cancel out each other if they're acting in opposite directions, right? Two forces can only cancel if they act in opposite direction. Electric force is upwards, so magnetic force should be down.
But how do we know they're canceling each other?
Because the question says the particle should pass undeflected. It can pass undeflected only if the net force is zero. Write down these points, all these points. This will help you to decide how to approach in these type of problems. And this is a very, very important problem of magnetics. Can I scroll it? No?
Sir, could you scroll the thing up, sir?
Sorry? Up?
Yes, sir. Done, sir.
Done? So once you decide the axis of magnetic field, now you know that it's along Z axis. Then it's a hit and trial method, positive Z and negative Z. To decide Z axis, we use this concept F, V, and D are perpendicular. V is along X axis, F is along Y axis, then magnetic field can be only be along Z axis. You just have to decide positive Z or negative Z. Written?